Dean, if ESP exists, it has a dramatic impact on our worldview and certainly our concept of what science is. I would love it to be so. The scientific training that I have makes me quite skeptical. So I really want to approach the question of, does ESP and all of its ramifications make sense, both from an analysis of the experimental data and then what possible mechanisms can generate this? Mm-hmm. So what is the best data that supports the existence of things beyond the normal sense of the physical and physical senses that we have?
Before I answer that, I'll mention that the idea of making sense is an important element here, because we ordinarily think that the only way that you can be rational is for something to go through the senses. So in this way of thinking, ESP, extrasensory perception, is nonsense, meaning it is not part of the senses. Right. And so the two are sort of fighting each other, these two different meanings of it. Good. So what's the best evidence? It's not the case that there are individual experiments that you can then say, well, here it is. Here's the experiment that will convince anybody, because in science you shouldn't do that anyway. Nor is it the case that there are some people with amazing skills, they claim, who say, look at this, what do you think of that? Well, that's not based on that either. What the evidence that we have is repeated experiments based on people who don't make special claims. So just as in lots of mainstream psychology, a lot of ESP experiments, and by that I mean the whole field of ESP, are based on the equivalent of college sophomores. So we know a lot about ESP and college sophomores, or equivalent, meaning people who volunteer for experiments, because there are classes of experiments that have been developed. So we have one called the Ganzfeld telepathy experiment. Ganzfeld is a German word meaning whole field. It's a way of producing a fast sensory deprivation kind of state. So there we have a couple thousand experiments. The overall results are very, very clear in meta-analyses that something is going on.
Meta-analysis is summing together a whole different series of experiments to come up with a unified whole.
Different series of experiments looking at the same thing. Mm-hmm. Yeah, it's a way of collapsing them all and integrating them. Right. So that's in the telepathy realm, we have that. There's another class on dream telepathy. These are cases of telepathic connections in the dream state. There again, we have pretty good evidence that something's going on.
In all of these cases, as per what you've just said, the effect, if it is at all revealed, and there's some controversy, but taking that it is, let me give you that. Mm-hmm. The effect is a statistical analysis, whether in the individual experiment or certainly in the meta-analysis.
Right.
It's statistical, and it is a small effect. If this is such a powerful shift in our worldview, why is the effect always so minuscule?
Well, first of all, let's look at scientific disciplines that rely on statistics of weak effects in order to make a case. Well, there's psychology, there's sociology, there's biology, there's medicine, there's even physics, where ultimately science is based on measurement. Measurement is never perfect, in which case you're always going to have to use statistical arguments to make your case. Just to give one example of many possible examples, you take a case where you're testing a new drug. And let's say it's not a new drug, it's just aspirin. So aspirin, it turns out, has been tested repeatedly to see whether or not it prevents a second heart attack. Well, what is the size of the effect for which the FDA gave its approval that you should take aspirin for this? It turns out to be much, much smaller than the effects that we see for telepathy experiments. And yet the FDA and everybody buys aspirin because it shows this effect, which is really tiny. In fact, it accounts for far less than 1% of the variance in the experiments. So it's a really tiny effect. It took way over 20,000 people doing these experiments for long periods of time to see the effect.
You've used a wonderful metaphor, and that is, if the best people so gifted in ESP would go to a casino in Las Vegas or someplace, they would still lose all their money. It would just take them longer to do so.
That's right. So And of course, there in the casinos, the house odds are so weighed against you, you really have to be working at exceptional levels.
Right.
But so in general, we're talking about average people who are asked to do some kind of an ESP thing in the lab, and they don't even know that they have this skill. They're still able to show small effects. Now you can say, well, what happens if you start selecting people out who you think might do better? Do you get a better effect? And the answer is yes. So in the case of telepathy experiments, if you choose people for the experiments who are in some kind of creative profession, they're dancers, they're musicians, they're artists of some type, instead of getting the effect that we see in these experiments, they get about twice as good. So it's no longer a small statistical effect. It's now starting to get to a medium-sized statistical effect in terms of the way that we describe how effects are. It's not minuscule. It's actually quite large.
Well, I think there's some controversy there. Other people would have different views. But let's go to the other. One side is data. The other side is how to account for it. Because some would argue that even if we have some kind of an effect, but there's no theory that it all can support it, then we have to further question that data, because if there's no theory, something must be wrong.
Right.
And on the theory side, we're talking about kind of revolutions in how we view the physical world, if any of this is true.
Not so much the physical world. It has more to do with how we think our role is in the existing physical world as described by fundamental physics. So then fundamental physics, the idea of non-locality is well accepted. Well, we're part of that non-locality, so why shouldn't we occasionally feel or see things at a distance? So it's not so much that the physics no longer allows it. Actually, the showstopper back about 100 years ago was we can't think of any plausible physical mechanism at all which would account for things like two objects which appear to be separated but in fact are still connected in some way. Well, now this is a no-brainer, basically. We know from quantum entanglement that you can have objects that are actually separated, but they're not really so separate after all.
One of the challenges there is orders of magnitude and size, that the entangled objects are generally particles that are very, very small, many orders of magnitude below the size of our brain cells, where we at least apprehend information.
Right. But rather than arguing about scaling up quantum entanglement, the point of bringing it up was to say 100 years ago it was a complete showstopper. ESP couldn't exist. In fact, it was called error someplace because there was no plausible way of thinking of it. But now we do have plausible ways. So if you look in a historical sense about the way that science is slowly moving and evolving, it's evolved from a place where we didn't have any idea to a place where we do have an idea. It may not be the right idea, but at least it's moving in that direction. So when you think about then, how do we understand this from a quantum perspective, since that's the opening of the door in two ways. One is non-locality, the other one is the effect of observation on a system. Both of them are related to ESP. In the first sense, observation on a system because of the act of intention, somehow moving out, and non-locality for something to do with perception. They are distributed somehow in the world. So in order to connect quantum mechanics to this, you need to show that it begins to scale up into larger and larger systems.
Right.
If you've been tracking what has been reported in the literature, you find that one of the big goals here is to get it in larger and larger systems for the purely technological goal of creating quantum computers. And the rate of progress is very fast. So I think I can make a prediction that eventually we will begin to see not only macroscopic non-living systems, but we'll see non-locality in biological systems.
And so, from your perspective, if you combine the statistically significant data in different kinds of experience that you say the field has, with at least a possible mechanism, so between those two, you are able to make sense of the possibility that extrasensory perception is a real function of the real world.
Yes, but we should also keep in mind that science does not always need to be led by theory. In fact, most of the really interesting developments in science started first as observations only. Just to give one example, continental drift. It was an empirical observation. No one had any idea how it could work, and it took a lot more observation and theory development before people began to accept something which we all accept now.
The difference is, though, that uses the normal forces of the normal world, even though they may not have known it. You have to find some very special aspects of the physical world at best, and maybe something beyond our current understanding.
That's correct.